Good afternoon. Thank you for joining us for our webinar on WARDCAM basics. So this should run about an hour, maybe a little over, depending on if there's questions people want to get me to get in some other topics. So the idea with this webinar is basic run through of how to program parts for people who've had little or no experience with WARDCAM, or maybe been working with WARDCAM for a while and just want to see if there's anything you're missing. This is your opportunity to ask some questions and maybe see some different things. So only have really one slide here to show you, just overview of the idea behind WARDCAM. It's basically a DXF to DWG converter. It takes DXF, DWG files and converts them into CNC files. There's also a parametric shape library in there, so basic shapes that you can also program off of, and those shapes can be added to or customized. If you do need a different shape or something customized, you can contact us and we can take a look at that for you. No CAD functionality in WARDCAM because we figure nowadays most people have CAD or can go out and buy inexpensive CAD to get your 2D drawings ready. And then there's no nesting in WARDCAM. Basically, you bring in your drawing file the way that you want to cut it, be it a single part or multiple parts, and add your toolpath that way. For people that need nesting, we've got a couple different packages available for that. And then you can also do fixed bevel cutting in WARDCAM. So if you have a 5-axis head, you can program fixed bevel cuts, or you can also program for taper compensation in WARDCAM. And then WARDCAM can be customized for other OEMs machines, so we can just modify that post-processor to put out the appropriate codes for your machine if you don't have a WARDJet machine. So with that, we'll get into things. And I should also mention, if you do want a trial of WARDCAM, you can contact me, email me at jday@wardjet.com, and I can send you a link where you can download WARDCAM if you want to test it out. So when you do first start up WARDCAM, this is the first screen that comes up. So your choice is open a file or go into your shape library. The free draw thing here is more of just a fun thing where you can roughly sketch something on the screen, but we'll go into the shape library here. So if you are currently using WARDCAM, you'll see if you don't have the latest version, there are a few more shapes that have been added in here. So again, these can be customized. If you've done any sort of programming yourself, it's basically a XML file that defines these things, and it's found under the program data WARDCAM data shape definitions area, all those different XML files that if you have any comfort with doing any sort of programming, you can modify those things yourself if you like, or contact us. So I'll just run through a basic shape here. So first pass, just take this. So got your geometry screen here. And first of all, for the mouse, you got, if you have a scroll wheel on your mouse, roll your scroll wheel back and forth. You can zoom in, zoom out. If you hold down on your scroll wheel, you can pan around. If you're zoomed way in or way out, double click your scroll wheel and it'll zoom extends. And then for selecting geometries, by default, you're usually in the select mode when you come into WARDCAM. So that's this tool up here on the left that's currently highlighted. So if my select tool is activated, if I hold down my left mouse key and I drag a box from right to left, whatever I'm trying to select just has to be crossing or touching that box. So similar to if you've worked with CAD before, similar concept as far as selecting things. So if you go from right to left, you just have to be crossing or touching the item. If you're dragging your box from left to right, whatever you're trying to select has to be entirely within the box. So if I'm trying to select this outside ring and I let go here, it's not going to get it because it wasn't entirely within that box. You can also, if you select something and then decide that you want to select something else, you can hold down your control key and select additional items, or also deselect things by holding down your control key. In the lower right-hand corner, right now we're in imperial mode. So if you are working in millimeters, you can toggle this between imperial and metric to switch for that. Lower left-hand corner, we've got XY coordinates where my mouse is on the screen. So there's no measure tool here in WARDCAM, so if you don't know how big something is, you can basically hover your mouse over one edge here. So if I look down in the corner, I see that my X coordinates when I'm at about the 9 o'clock position is around 5, and come over here and I see it's positive 5, so that's 10-inch diameter. So that's how you can get an idea of how large things are here in WARDCAM. Up here in top left-hand corner, you have a layers tool. If you get a drawing file that's got layers in here, you can go into here and you can hide certain layers to make things easier to work with. I've got an example like that I'll show you later. And then going down the left-hand side, you got various tools that you may need. So for example, delete tool, if there's extraneous geometry in your drawing file you want to get rid of, you can click on the delete tool and click straight on an item. You can also select something. So if I select that, I can also just hit my delete key on my keyboard to delete things. And there's also the undo and redo tools up here. So if you mistakenly delete something, you can undo and redo. Control Z and Control Y also work for that. Ortho button up here. So if you are drawing in a line or moving something, copying something, if the ortho button is on, then you can only move in your do things in your 90-degree increments. So as I mentioned, there's no CAD in WARDCAM. We do have these tools over here for lines and rectangles for cleaning things up. If you get a drawing file in and it's missing a line, you can draw things from endpoint to endpoint, but you can't draw a line of a specific distance. So I can't tell it that I want to do a 3-inch line, for example. Point command, we can talk about that one later. Delete, I just showed you. Trim, so if you have, again, you're cleaning up a drawing, a couple lines that you want to get rid of, you can click on your scissors here, trim that up. And then the explode is used if you have geometries that are joined together. You can explode it to more easily modify things. And then these buttons down here, you've got move, copy, rotate, scale, and mirror. So if I wanted to cut 2 of these, I can select it and click on the copy button. When you start any of these commands, after you've selected the thing, down here at the bottom, it'll prompt you select a base point for whatever you're doing. So select base point for copy. As I hover near the center of that circle, you'll see a little blue circle shows up there. That's the snap for the center of the circle. And then I can move this around and copy it. And again, since my ortho button is not on right now, I can go in any direction or turn on my ortho button and just go in 90-degree directions. So that's the copy command. Move command works in a similar fashion. If I wanted to cut these in different orientation on the machine, I can select it, click on the rotate button. Again, it's going to prompt me down here, select a base point for rotation. So if I want to rotate around that center point there, when that blue circle shows up at the center, I can click on that. And since I do have my ortho button on, I can just move around if I want to rotate this 90 degrees. If I want to do it at a different angle, I can just start typing in a number and this dialog box will show up to specify the angle. And the scale tool is here. So if this came in and this were either maybe drawn in metric and you want to scale it up or down, or is it drawn 2:1 scale or whatever, you can select items, use your scale, choose where you want to scale up or down from. And similar to the rotate button, for that scale function, you just start typing in a number. So if I want to make this twice as big, just start typing in 2 and this dialog box comes up. And then the final one down here is the mirror command. So probably not a great example, but if I want to mirror these parts here, select them, start the mirror command, again, select space point for mirror. So you pick a point and drag down and it'll mirror them over there. So we'll just go with this setup right here. And we'll go ahead and at this point, hit our next button. So on the screen here, part screen, you select your nozzle orifice combination, your material, and your thickness. And we'll get more into those here in a bit. Once you've done that, top right-hand corner, you can hit your next button. And this screen here, the Toolpath screen, is where we add our toolpath. So simplest form, top left-hand corner, you can click on the auto button and it'll put our toolpath on there. So the blue lines are the rapids and the red lines are the cuts. And then we're adding our lead-ins on here. So it'll pierce here, go in, cut around, and go on to the next cut. You'll see the red line is offset from the drawing line, that light shaded part there, to show that we're offsetting from our geometry by half of our stream diameter so that we can hone in the accuracy of our parts. Over here, top right-hand corner, you got your cut order box, so you can click into here. As you click onto these different cuts, it'll highlight where that cut is in the cut sequence. And if you wanted to change cut sequence, you can select a cut and hit the arrows here to move things up or down. And we'll come back to talk about some of those other tools here in a bit. Top right-hand corner, hit the next button. And then this screen here, top left-hand corner is where you make your CNC file. Click on CNC and it'll create our code. And if you have the option turned on, it'll automatically open up that CNC file for you. So we do use standard G&M codes, so it's pretty straightforward code if you're familiar with it. And as I said, this code can be customized if you do have somebody else's machine that you want to use WARDCAM with. After you've got your CNC file, you come back into the WARDCAM screen. The report tool will be active. You can click on this, and this will generate a little HTML file that's got information about the name of the part, image of the part or parts, nozzle orifice combination, material, thickness, etc. Box here for notes if you want to type any notes to your operator, as well as estimated cutting time. And then down here is a section that can optionally be turned on or off that shows cost information, so you can plug in information like cost of your machine, overhead, things like that, what you're paying for abrasive, and it can give you an hourly breakdown for operating cost, as well as an estimated cost per part breakdown. And then we have an optional barcode scanner where the operator could just scan this barcode and it would automatically load this file at our controller. And as I'm going along here, if anybody has any questions, feel free to type them into the questions box and I'll try to answer those as we're going along. So that was basically a quick overview of the process. Now I'll kind of delve into things a little bit deeper here. So I'll open up another file. So we'll just go top right-hand corner, hit our next button. And I will go ahead and change this. We'll say that this one's going to be 1/8" aluminum. Hit our next button, click on my auto button again. So on this toolpath screen, a couple other things you can do. I showed you earlier how you can click into here and reorder cuts. So if I'm looking at this cut sequence here where it's cutting the slot on the right and then the slot on the left and then the hole in the middle, if I want to optimize that a little bit, I can basically find this cut in the sequence and click on my arrow key and move that around. You can also change lead-in position. So if you don't like where WARDCAM put the lead, you can just left click and change your lead position. WARDCAM's primary objective in life is collision avoidance. So if you do ever start changing leads around, you want to be careful that you're not going to put yourself into a situation where you might catch a nozzle on a slug. So if I were to put the lead on this side, there's the potential if I don't lift my head between cuts, that if this slug tips up, that it might the nozzle might catch that as it rapids over to this hole here. So if you do start manually moving leads around, you just want to make sure that you don't put yourself in danger of catching yourself on a slug. And then other thing you can do in here is change your cut qualities. So if you aren't familiar with abrasive water jet cutting, the basic concept is the faster you go, the rougher your cut is going to be, and the slower you go, the smoother it's going to be. And those are usually called either Q1 to Q5, or in WARDCAM, we call them smoothest to fastest, with the mid-range being called normal. So these inside holes here, if I wanted to cut these slower for a smoother edge, straighter edge, I can either select these individually, click one at a time and change quality, or if I hold my shift key down, I can select multiple leads like that. I can also hold my control key down and select multiple leads. However, I select those. If I want to change all those at one time, I can now come down to my leads box here and choose whatever quality I want on those. There's also similar functionality for just a portion of a cut. If there's one portion of the edge here that I want to cut at a different feed rate, rather than using this leads box here, I can go down to my partial qualities tool and expand that and choose a different quality. And the way this one works is you click 2 points. So if I want to have this quality between this point and this point, click those 2 points, and then you have to let WARDCAM know which way going around that cut you want to apply that quality, because it can either apply it between those 2 cuts that way or that way around the geometry. So if I want it in this area here, when that's highlighted, I just left click and that'll lock that in there. So if left click, and then left click again to lock it in. So you could have 5 different qualities on a part if you wanted. So left click, and lock it in. So let's see here, got that. And then one word of caution, if you ever click on the delete all button unintentionally, it will delete all the cuts and there's no undo for that. So just have to kind of be careful about that. If that happens, you can then just click on the auto button again, it'll re-add your path. And then again, once we're at this point, there is also this fast forward button up here. So if at this point you just want to go ahead and just create the CNC file and the report, rather than having to hit the next button and click on the CNC button, you can just click on the fast forward button and it'll take it from that point forward and create the CNC file, and then also generate the report. And drag that over. All right, so let's go open up another one. You'll note also down here at the bottom, we've got tabs going here. So as you open up additional files, you can switch back and forth if you're working on multiple parts at the same time. If you're done with a part, you can of course do save and save it as a WARDCAM file. If you're not going to save it, you can just click your, when you're hovering over the tab, you can just click your scroll wheel and it'll prompt you to close it. Let's open up another one here. All right. Take a look at the machine and material databases. So there's several machines that come by default with the system. If you need to add a different nozzle orifice combination, then you can go up to this database area here and you can go into machine database. So here I've got a few machines set up. So if I wanted to cut with a different nozzle combination, say a 1230 nozzle combination, I can highlight one of my machines here and down at the bottom, click on Add Machine. It'll make a copy of whatever machine that I have selected at that time. So here we have the new AWJ 2D 1030. So this name box here, I can just click into this and I can give it whatever name I like. So we'll call it 1230. And then you have options about whether this is a water only machine, which in this case it's not going to be, but if this were, we would click this button on. So if you turn that on, then the things related to abrasive go away. And if this were a 5-axis machine, we could click that, and then that would give us tools where we could apply bevel cuts to parts. And then you got maximum nozzle diameter and nominal nozzle diameter. So the idea with the maximum nozzle diameter field is WARDCAM is going to look at geometries and figure how far the stream can get into a tight geometry before it's actually going to start cutting into the part. So the way that I usually diagram this is, let me just bring this over here. Draw this in our fancy little package here. So if we're cutting a little, say, sheet metal gauge measuring tool like this, and this part here is, say it's only 1 inch, And we're telling WARDCAM that the maximum that we're going to let our stream grow to is 032. And let's say that represents 032. I guess I'd make it a little bit bigger so I can grab it. There we go. So basically WARDCAM is going to look at a geometry like this and figure out how far down into something like this that it can get before it's going to start cutting into the part. And once it determines how far it can get, then that's where it's going to turn around. So if you looked at the CNC file, you would see it basically coming to here and coming out at that point. If you did want to get a little bit further down into this notch, then you can reduce this maximum nozzle diameter down to the nominal size, and then you go a little bit further down. But that's what the purpose of the maximum nozzle diameter field is. And then pump power has to do with calculating how many heads we can run off of a certain nozzle combination. So we'll just say this is going to be a 50 horsepower pump. Maximum cut velocity that you want to allow on materials. So you can set this to maximum speed you want to be able to calculate. And then you've got things for abrasive flow rate, and then your orifice size, pump pressure, and then maximum velocity would be the maximum rapid speed of the machine. So all these things go together to calculate the feed rates in the material database. So if you do change anything in here, after you change it, so if you're running a little bit more abrasive or you're running your pump at a little bit higher pressure, if you change anything, you can click on this recalculate materials values, and all those feed rates will be updated accordingly. Now, before I do that, I need to copy over feed rates from another machine or material database from another machine. So click on copy materials, copies that over, and then we click on recalculate the values, and the feed rates would be updated based on the numbers that I have up here. And if I click on this advanced button down here, there's a few other fields that show up. Fields telling WARDCAM where we're pulling our post processor and such from. So we can, as I mentioned, do other machines. So the post processor is written in Python. So again, that's something where if you were comfortable with it, you could do something like this yourself. More typically we would do that, but that is customizable. So basically telling WARDCAM where we're pulling from for the post processor and various variables for the M codes, G codes, things like that, and then where the report's coming from. And most importantly, down here, once we turn on this advanced tool, where we're going to start from and where we're going to end. So we're telling WARDCAM that our 0 point on our machine and for our programs will be lower left, and we want to work towards the upper right-hand corner here. So when WARDCAM is adding its toolpath, it basically works backwards from that point, again, to try to avoid collisions as much as possible. And once you've made those changes, click on save and exit, and now we'll have a new machine in our machine database here. So here's the new one I made, and then we've got the materials that were copied over. So that's the machine database. Now we'll delve a little bit into the material database. So if you either want to add a material or add a thickness, you can go up to database and then material database. And so if we wanted to cut this part out of 1.5" aluminum, currently not in the database, I usually highlight something that's close to it and click on add material. And similar to the machine database, it's going to make a copy of that. And then you can just come over here and you can change your thickness. So we'll say 1.5" thick. And then I click on calculate, and you'll see when I click on calculate that these feed rates are going to change, because right now these are based off the 1" thickness that I copied. So I click on calculate and those feed rates change. And feed rates are based off of, as I mentioned, the pump pressure, nozzle orifice, abrasive flow rate, as well as this machinability number. So materials that cut faster than steel have numbers that are greater than 1, and materials that cut slower than steel are going to have a machinability of less than 1. So for example, if we go down to stainless, we've got a machinability of 0.9, so basically it cuts at 90% of the feed rate of steel, and then aluminum is typically 2.9. If you got material that's cutting a little bit faster, a little bit slower because it's a little bit harder, a little bit softer, you can change your material. So if I were cutting a 5051 aluminum, I can, again, click on add material, mix a copy, and or whatever the grade of aluminum it is, and then adjust our machinability, say 2.7. And if you need to determine what that machinability is for any material that you don't know, you can just put it up on your water jet, do a series of cuts, and based off of that, determine where you want these feed rates to be and kind of work backwards to determine that machinability number. And then for each thickness, you've got your 5 different feed rates from the slow smooth to the fast rough. And on each of those also, you have a high speed and a low speed. So WARDCAM will always try to get up to the high speed, and then when it comes to a corner, it'll slow down to the low speed. These can be manually overridden, so if you wanted to cut something at different feed rates, you can just click into there and change it. And if you want to kind of keep people from coming in here and mistakenly changing that, there's this lock button that you can click on. And if that lock button is turned on, if I click on calculate, it's not going to override those. It obviously isn't super foolproof because it's easy enough where somebody could just click on here to turn that off and do that, and it's going to reset things, but it does at least one level of protection to help preserve any changes that you might have made. And let's see, we've got the feed rates. So if I click on this advanced button down here at the bottom, a few other tabs will show up here that we'll get into. Leads tab gives you information about your lead-ins for your inside, outside, and other cuts. And you can also specify whether you want to use circular piercing for your leads. So there's a couple scenarios where we can use a circular pierce. Either if you're doing low pressure piercing of a material like glass, which might shatter if you pierce at high pressure, we'll typically do a low pressure circular pierce. So the pump will go into low pressure and go over and make a bunch of circular pierces at the various pierce points, and then the pump will go into high pressure and then pierce through those holes that you've already made and do its cutting. The other scenario that you might use a circular lead-in is thicker material like this, where rather than having to use maybe a 1 inch long lead-in to give yourself enough time to pierce through the material, use a circular lead, it'll sit there at the initial pierce and make a bunch of revolutions based on the numbers that we have in here before it pierces through and then start to move into the material. So we've got those buttons there for turning that on and off if you want to use that. And you can also choose to use arc in, arc out if you like. Usually that's for water only. People arc in and arc out. Usually for abrasive cutting, straight line lead ins and lead outs is the best way to go. And then you've got choices for lengths of lead ins and such for inside cuts, outside cuts, and then other cuts. So the other column I'll talk about here a bit is used if these other two columns fail. So if you're doing a part that has really small holes on the inside, we're telling it to use a lead-in length of 0.2. So if we have a hole diameter of 0.187, it's going to look at that inside column and try to put a 0.2 long lead-in on there. It's going to fail, and then it's going to look over at this other column, and then it's going to use whatever we have in the other column for our lead-in length if it can. Again, if this number is set too high, then it's not going to add the lead into that cut at all, and you can come into the material database and adjust this. So that's what the other column is for. The inside and outside are always kind of self-explanatory, and people are always kind of wondering about the whole other column there. So we work our way down here, you got tab width. So if you have a small part, you don't want to fall into the tank. If you set your outside tab width to a positive number, then it's going to leave a small amount of material at the end of the cut, as shown here in this little image. And then you can just break the part out of the material, and this can be adjusted depending on how large of or small of a tab that you want there. If you put a negative number in, then it's going to cut past where you let in. So if you're getting a little bit of a nib on the back side of your cut and you want to cut past here a little bit, we can just put in a negative value of whatever it needs to be. And so here's going to come in, go counterclockwise around the inside hole, and then it's going to cut past there by this, in this case, 40,000 number. And we've got our length of our lead-ins. Lead out, if I have a little bit of a lead out. So typically we like to, at the end of the cut, move a little bit away from the edge. So when we're pausing to turn water and abrasive off, it'll reduce the ding that you could see there. And then the angle that you want to lead in and lead out at if you want to change those numbers. If the advanced button's not on, then the angle fields aren't shown, but you just click on your advanced button and then those fields will show up there. So let's see. All right, so yeah, I just did have a question as far as adding a tab onto the part there, so hopefully that answered that question for you. If not, let me know. But basically that tab width field there, put that on your outside cut and that'll keep it from falling into the tank. So the other tabs that show up when the advanced button is turned on is the ramping tab. So when we're approaching a corner, coming out of a corner, we're going to start slowing down a certain distance away from the corner, and then we're going to use a certain distance to ramp up to full speed if we can, depending on the length of the geometry. And then we got a number of lines of code that we're using to get from the low speed to the high speed. So normally these numbers are pretty good and you don't really have to adjust these, and that's why it's normally not shown unless you hit the advanced button. But if you do want to adjust those, that's where you can do that. The marking tab, if you want to do engraving or etching, you can do that through the marking tab. So 3 basic parameters that you can adjust for marking are the feed rate that you're doing the marking at, whether you want to use abrasive or not, and whether you want to do it at low pressure or high pressure. So here you can specify your feed rates and whether you want to use the abrasive and low or high pressure for that. And then if you want to have a short little dwell when it does that, the initial pierce, you can specify that. Usually you'll set that to 0 to minimize any sort of little divot that you might get at the initial marking point. And then finally we have the other tab. So this one controls the feed rate that we use for our lead ins and lead outs. We're generally going to cut our lead ins at about half the speed that we're going to be cutting the geometry at, and that just gives additional time for the stream to get through the material before it gets to the actual cut. So we found that 50% works pretty well. And then when we get to the end of the cut and we do the lead outs, we slow down a bit more for to allow the stream to catch up for the lead out. So those numbers are usually pretty good and can usually leave those where they are. If you are doing circular piercing, you can specify diameter of your circle pierce and the number of turns that you want to make for that. And then this pierce dwell here would just be if you're just piercing a point, you want to mark a location to drill out a hole. That's how long it's going to pause to do that. So that would need to be adjusted based on the thickness of your material. And then the DB material blowout distance is one that I'll get into at the advanced topics. It's basically allows, if you've got material that's might delaminate when you pierce, if you plug a number in here, then it's not going to put a lead in any closer than that to an edge of a part. So that's what that one is. And if we did have 5-axis, we can tell whether we want to do tilted pierce and such for those, but since this is not a 5-axis machine, we don't need that. So we'll save and exit. So in our material database now, we'll have that new material that I made, and there's my thickness, and I can hit my next button, and I can hit my auto again. And again, if I want to change my lead-ins, I can click around. Again, just to review here quickly, if I want to change edge quality, choose partial qualities, click a couple points, left click, lock it in there. If you get to this point, you decide you want to change your length of lead-ins. So you want to make your lead-ins a little bit shorter on those holes. Under the leads area here, you can click on this edit leads, and it brings you back into the material database for that material and thickness. So if I want to shorten this up here, I can click on that, click on save and exit, and then if I just click here, then it'll re-add the lead and shorten that up. And then we'll hit our next button, top left-hand corner, click on CNC or do your fast forward button and make the CNC file, and then make the report. So one thing I will point out about circular piercing is that if you decide to change the number of revolutions, you'll need to delete and then re-add your toolpath. So if we look at this file right now, where we're going basically in the text file from 15 to 24 on our line numbers here, if I go and decide that, hey, I need some additional turns in there because I didn't get through in time, go into my material database and click on my advanced button again and go to other, and I say, all right, let's do 10 turns. save and exit. If I just hit the CNC button and replace, and we're gonna reload this, you'll see that the lines of code here didn't change. It was the same number of lines of codes, even though I told it to do 10 turns instead of 3. So to get it to actually recognize that change, you just have to go back to your toolpath screen, delete all, add your toolpath again, do whatever changes we did before, and then click on your CNC file. And then once we reload this, now we've got the additional revolutions in there. All right. You may have also seen that even though I told it to do 3 turns, that that first one, there was some additional turns in there. Up at the top here on this last screen under the Options tab, go to Edit Variables. There's various things that control the way that the machine functions, be it the G&M codes that we use to tell it to turn water and abrasive on, whether we've got height sensor, the machine tab. We've got information here for the costing of the machine of the parts that I showed earlier on that report, so you can plug in things like what your machine cost is and things like that, whether you want to generate the report, whether you want to print the cost information. We'll delve into this one more on the next webinar, but there is a parameter on this water jet tab where it's extra pierce turns. So if I told it 3 turns in the material, it's also going to add on additional pierce turn based on that value there. So let's see, next we'll take a look at a file that's got a little error in it. So we'll go to this one here. So we open up the file, all looks good. Top right hand corner, I hit my next button, and the outside geometry is gray, so normally that would be green. And we see up here we got this little point indicating we got something going on there. And if I use hover my scroll wheel, hover my crosshair over that, use my scroll wheel, zoom in real close, I see there's a little line segment here. So something didn't quite get cleaned up in CAD. Without zooming out, I can just go back, top right hand corner, click on my geometry button here, go back to the geometry step, and I can clean this up. Now, first time I did this file, I figured that would need to be trimmed up, so I used my trim tool here and I tried to click on that, but actually this is its own separate line segment, so it can't be trimmed up. Rather, can use the select tool and drag a box around that and then delete it. Double click my scroll wheel to zoom out, hit my next button, and then all is good. So let's see here. Let's switch to a different thickness here, different material. So at this point here, if I hit my fast forward button, it'll go through again, add the toolpath, create the CNC file, create the report. So there's that one. And one other thing I'll show you here is if you want to put a lead on a corner like this, a couple ways of doing that. So for a little bit better cut quality, rather than having the lead here, I want it more on this 90-degree corner here. So if I click onto this corner right now, because of the tab and the angles I have set up, it's gonna do something like that. If I want that to more come in tangential to this edge here, if I go into edit leads, a couple options that I can do on this. If I set the tab width to 0 for the outside cut and save and exit, and then click on that corner, then it'll go straight in and then straight out. Now this part here is probably big enough where it's not going to fall into the tank. If it were a smaller part, I didn't want to fall into the tank, so I still needed the tab there. Then you can edit your angles, because again, if I put my tab width on here and try to put that on there, it does that. So to both have a tab and have it go tangential into that corner, click on my advanced button, set the angles to 0 for in and out, and then click near that corner. And let's see. Let's see, in, out, tab, width. Let me make that a little bit smaller. Yes. Tab width, outside cut 60, see what's, actually, sorry. Because I've got also, I got lead in, lead out there, so set that to 20 thou. Drop that back. And I will get this right. So you can tell this is live, right? So tab width, let's set that to 0. Boom. We'll get there. In length, sorry, in length 0.2, out length 0. There we go. So, all right. So next, do a quick one here. It's got an example of part with layers. So if you do get a drawing like this that's got layers, as I mentioned early on, you do have the layers tool up here. So you can basically click on the eyeballs here next to the layer names and hide layers. And the one thing you have to be careful about on this is not to click on the layer name that you have turned off. So what sometimes has happened to me, has happened to a customer sometimes, is they go turn off the layer, they click onto that layer, and then they hide the layer. And now we're currently on a hidden layer, and then they decide that they want to make a copy of this and maybe spin something around. So they select it and they use the copy command, click on copy, base point for copy. I come up here, I see my little ghost image, I left click, and I'm like, where's it going here? But because I'm on the layer that's hidden, then we don't see that. So if I then activate that layer, then there's all those parts that I copied. So just be a bit careful about that. If you do end up turning layers off, that you don't also put yourself on that layer that you've turned off. So we'll turn off that dim one again there. And then finally show you a part of doing some circular low pressure piercing. So I'm just gonna go ahead and go for a part from the shape library here. So if we're gonna cut this part out of glass, we hit our next button, and let's see, I'll just switch to 1440 machine, 1440 nozzle combination, switch to glass, switch to whatever thickness. And again, if we go into our material database, so things like glass, we have this fragile button that's turned on. And if that's turned on, then by default, we use a circular pierce. And those two things in conjunction tell the pump to go into low pressure, do the circular pierces, and then come back and do the other cutting at high pressure. So we'll just go ahead and show you how that would work. So we've got our material selected, hit our next button, click on the auto button. So if we zoom in, we've got our circular pierce there. Hit our next button, click on CNC. So up here at the beginning, we have got our code to tell the pump to go into low pressure. We've got a 8-second delay. We've also got a optional M00 in here. If you've got a manual mini hopper and you want to adjust your abrasive flow, make sure that you got time to adjust that abrasive flow rate for the lower pressure so you don't overwhelm the cutting head with abrasive. You can put that in there. That's something that can be taken out if you have a mini hopper that automatically adjusts the abrasive flow. And then it's gonna go and do a bunch of circular pierces. So it goes around, does those circular pierces at low pressure. And then when that's done, pump goes up into high pressure. Again, there's a delay to make sure it gets up into high pressure and the optional M00. So again, to give your operator time to adjust the abrasive flow for the high pressure, and then it'll go back and pierce through those holes and do the cutting of the other geometry. And a couple other features here we can show you. So we'll open up this one. So this one here, let's see if we've got some layers that we can shut off. We'll turn off our dim layer here. I'm just gonna go ahead and delete that. So I'm just gonna select that and hit my delete key. So just some example again, how you can clean things up. So if we want to trim that up, hit our trim command, click on those lines, get rid of that. Got a big gap here I want to close up. I can use my line command, draw in a line here to close that up. The idea with this one here is we're going to etch these numbers, the 1, 2, 3. We're going to cut this as a open contour slit cut. We're just going to pierce where this hole is going to be because it's too small to actually cut with the water jet given its diameter. So to signify that we want to pierce something, I can use this points command, and I just hover near that center of that circle where that blue circle shows up. I just left click and puts a point there. And since I'm not actually going to cut this circle, I'm just going to use my select tool and I'm going to delete that. And then I've got a point out here to show the idea of an optional stop, where you could have the cutting head move over to here and stop if you want to inspect the quality of the etching or whatever the case may be. So we got that. We'll hit our next button. So I haven't talked about things over here. So over here, we've got options for marking, open contour cutting, and point functions. So this open contour down here, we're gonna cut this, and it's considered an open contour because the start point and the end point don't coincide. So if I wanna cut that, I activate the open contour cutting tool, and I can select a quality for that. So if we wanna make that look nice, choose the smoothest. Whatever end of the line I click at is gonna be the end that's gonna pierce at. So my left click adds it up here to my cut order box. And then if I want to etch these numbers up here, over here on the right, I can activate my marking tool. There's no quality selection for the marking. As you recall, on that material database, we had the fields there. We were just told at what speed we want to do the etching at. So I'm just going to left click, and as I left click here, it's going to add these to my cut order here. And then this here, we're going to pierce. So if I go to point functions, click that. There's a few different options here. Pierce, drill, tap if you have a drill or tap on your machine, or optional stop. So if we're going to pierce this, click on abrasive pierce and click, and it puts that into my cut sequence. And then this one out here, we're going to do a stop there. So we choose stop and click, and there we go. So then once you've got that, you can hit your next button. And what we're going to see here is that part of this geometry is going to disappear based on the nozzle orifice combination that I chose. So because I was told I was using a 1440 nozzle combination, it's got a 40 thou stream width, and the geometry here must have been less than that stream width. So when I was showing you earlier about that feature where WARDCAM will try to figure out whether it can get through a certain geometry without damaging it, it says, all right, this area in here is too narrow. I can't get into there, so we're just going to turn around here. So what we'd have to do in this situation is choose to do this out of a different nozzle combination. So we change that, and we go back to whatever material we had chosen before. And let's see, hit our next button. And so now, with that smaller nozzle orifice combination, it's able to get through that area and cut that geometry. And we'll go ahead and switch this for the rest of it to be smoothest, and I'll hit on my auto button. And we got that. So again, if I wanted this to be more on the corner, just to review that here, we'll click on Edit Leads, and we'll set our tab width to 0, and we'll do 0 lead in angle, 0 lead out angle, and click, and we got our lead on the corner. And then geometries like this, sometimes you might find you want to move things around based on where it's going to be piercing. So like this lead in, I might put that more maybe up here. Might want to shorten up some of these lead ins. So we can shorten up our other lead in. We can shorten up this one also maybe, since it's thinner material. And we can optimize our lead position. So something like this, don't know that I don't necessarily want to pierce there and cut across there. Again, maybe I'd put this more up here and put that in the middle. So sometimes when you get more involved geometries like this, you might have to just optimize that, that location. So once we got the toolpath the way we like it, hit our next button, click on the CNC button, we'll create this. All right, so basically what we've got here at the start is the etch, and then we've got the numbers that, I'm sorry, the first one was a slit cut, and then we've got our etching, which we had told it to do with abrasive, so that's why it's got the M70 there, and so it does those. And then it's gonna go over and it's gonna do that abrasive pierce at this location here. So we've got a 1/2 second delay where the water and the abrasive turn off, as well as 1/2 second delay that we told it we want a pierce delay. And then rapids over, and in this case here, puts an optional stop, M01, or you can make that M00 if you want to force the stop. And then it's gonna rapid over and then start doing the rest of the cutting. So one final thing I'll show you here in the minutes remaining. Again, if anybody's got any questions, feel free to type them in. You can email me later if you have any questions. Just to show you a part with 5-axis bevel cut. So I'll just go back into my shape library and grab this one here. Let's see. Distance from edge. We'll move these in a little bit. Okay. If we want to cut this with 5-axis, I've got a 5-axis machine set up here, and we'll go with the ever-present 1/4" aluminum, hit our next button. So since I've chosen a 5-axis machine, over here on the right, we now have a Bevels tool. In order to add any bevels, first you have to add a toolpath to your parts. So I'm just gonna click on the auto button here to add vertical cuts. So if I want to do a countersink on these inside holes here, can activate my Bevels tool, and you can choose from either a top or bottom bevel. And as I click on those, change those, it'll show you what it'll be doing. And then the angle of your bevel cuts, and then how deep down into the part you want that to go. And by default, it's going to start out at 1/2 of whatever your material thickness is. And if you want this to go all the way around a geometry, you turn on this whole contour tool, and then there we go. And then I just left click and it'll add my bevel cut on there. So that blue line indicates where the tooltip is going to go around to put a hole, a bevel cut countersink on that hole there. And then you can do the same thing for the other geometries. If I want to switch to be a bottom bevel, can click. And so the cutting head has to be inside that hole in order to get underneath to do a bottom bevel on that hole there. And then on the outside, if we just want to do a bevel along a portion of an edge, I can turn off that whole contour button. And then similar to the qualities command that we did earlier, click 2 points. So I left click, and then tell it which way that I want to put this bevel around this geometry, and then left click again. And so tilt over, in this case, this is a bottom bevel. So, and if we also want to do a top bevel along there, give us a little X cut on that edge, click and click and click. And hit our next button, CNC. All right. So now, since we've told it that we're using a 5-axis machine, puts in A and C codes. So A is going to be the angle it's going to tilt over to, and then C is the angle that's going to spin the cutting head around to. So got a 45-degree bevel cut, and then a vertical cut, and then 45-degree bevel cut and vertical cut, and so on. So that covers what I wanted to go through today. Hopefully this has been informative for you. And so if you have any follow-up questions, you want to do some one-on-one time, you want to download a trial of WARDCAM, email me, jday@wardjet.com, or give me a call and can help you out. So with that, I will go ahead and sign off, and hopefully everybody has a great day. Thank you.